Now, can we now move to the next one? You still know how to determine the coordinates of the turning points? I think now you are comfortable with this one here. Right, now, from here now, what I want you to do now is the next question, which is question number 3 here, which says now, draw a sketch of F. Draw a sketch of F. What is a sketch of F? Now, you know, before you sketch the graph, you need to have the x and the y intercept. We did that one. You also have the turning points. Now you can be able to sketch the graph. Of course, for these functions, because we have everything, I'll also give you 3 minutes. Then after 3 minutes, then you will show me your answer there. I know how I will see that answer, but of course, you must show me your answer so that at least I can see if you are right or wrong. After 3 minutes, then we'll come back to this one. Right, thank you, boys and girls. Yes, there are a number of questions that are still coming through, which is good. Boys and girls, remember I said earlier on, if you really need to ask something, you're not sure about something, please, you can ask that one. Of course, I will respond to your question immediately after we have sketched this graph here. Good. Now, boys and girls, when you sketch the cubic functions, you remember, we need the x and the y intercept, and we need the turning points as well. Remember the value of a name. The value of a also very important. Why very important? Because it will show us if we have the minimum turning points first or the maximum turning points first, which is very, very important. Right. Let us look at this one quickly here. I would say this one is 1, 2, 3, 4, 5. And then minus 1, minus 2, minus 3, minus 4, minus 5. Good. And now we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And now from here, that is minus 1, minus 2, minus 3, minus 4, minus 5. This is the y-axis, and this is the x-axis. Good. Now, let us go back now. What was the y-intercept here? It was positive 3. Y-intercept was positive 3. Then we indicated the y-intercept, y-axis 0. That is a positive 3. Now, x-intercept, we have what? We have minus 3. That is a minus 3. Y is 0 here at this point, as well as positive 1. Also here at this point, y is also what? Y is also at 0. Good. Now we are done with the x and the y intercept. Is that correct? And I can see that you did the same thing. You started with the x as well as the y intercept. Good. Now let us now go to the turning points. Let us now go to the turning points. Right. And then minus 5 divided by 3 here. Minus 5 divided by 3 here will give us negative 1,7, right? Negative 1,7, yes, negative 1,7, it will be somewhere here. But boys and girls, remember, negative 1,7 is a point with what? With a positive 9,5. Now it means now we must look for 9 and 9,5. We say yes, 9,5. No, it's close to 1. Yes, 9,5 there. Okay. Right, the coordinates of this point here, of course, it must be what? It must be negative 1,7 as well as 9,5. But once I know that if the coordinates of A, no, if the value of A is greater than 0 there, then I know that this point as well, it must be the maximum. It means the functions will start doing what? Increasing first. Now, the function will increase first and then decrease after. Right? We start first with the maximum turning points. Great. Of course, the second turning point is 1 and 0. There, of course, that is the turning points here. And I can just also indicate so that at least I try to make my work very easier when I go and sketch this graph. Now, what is next now is just to join this one. I know this one must go and pass through what? Negative 3 on that side. And now it's 10. And then from this part here, where do we go? We go to the y, intercept, and now we join this one now. We see we have a very smooth curve now of a cubic function. Can you see this one? Yes, it's very important here. Right, like I said, the function increasing, it means the gradient of the straight line is positive, decreasing, gradient negative, increasing, then gradient positive, negative. Good. Now, boys and girls, I think you have the same shape as mine. And the smooth one, you can see mine is very, very smooth. It's very nice. Now, I didn't use the ruler to do this curve here. Right, thank you, boys and girls. Now, before we go to the point of inflection, which of course is very important, boys and girls. Now, let us respond to these questions quickly. The question here said, please help us to determine the value of x if the gradient of the tangent to g of x. Now, we must find the value of x. We find the value of x. Now, if the gradient of the tangent to the function gx is equals to minus x squared and then plus 2x minus 1 is 10, right? If the gradient of the tangent to the graph is 10, right? Now, like I said, what's important is you must understand, when you talk of the gradient, what is it that we are referring to? We are referring to the derivative. Of course, the function is given. We don't have the value of x. You remember now, even though we didn't look at the tangent today, that when you determine the gradient of the tangent line, what is it that you need to do? You need to determine what? You need to determine the gradient first, the derivative first, and thereafter, after the derivative, what do you do? Now, you'll be given the specific value of x that will substitute in the derivative so that you know that you are defining the derivative at that point, right? Now, what I would say from here, we know that g prime of x is equals to 10. We don't know what is the value of x that will make the gradient of the tangent to be what? To be 10. Now, what is it that we are looking for? We are looking for the value of x. Is that correct? Good. Now, it means what we are going to do, we must find the derivative of these functions here. We say, okay, g prime of x is equals to, this is going to be minus 2x squared, which is great, plus what? Plus 2. Is that correct? Because this is a 1 here. Then 1 times 2 is 2. Now, what is the derivative of minus 1? That is 0. Good. Now, we have g prime of x is equals to minus 2x squared plus 2. Right. What is it that we know? We know that the gradient of the tangent, we know that the gradient of the tangent is what? Is a positive 10. The gradient of the tangent is a positive 10. Now, this is the gradient at any point. But at that specific value, the gradient is 10. Now we want that specific value of x that will make the gradient to be 10. Right? How are you going to solve this one? We are just going to equate the two to say minus 2x, minus 2 not squared here in Parma. That is minus 2x plus 2. That will be minus 2x plus 2 is equals to 10. Is that correct? Of course, yeah, we need to correct this one. It was supposed to be because when you find the derivative here, that will be minus 2, and then minus 1 there, that will make this one exponent 1. Good. That is why now you have minus 2x plus 2 is equals to 10. And then from there, you have the linear equation. You just solve the equation. Unknown one side, minus 2x is equals to 10 minus 2. 10 minus 2 is 8. And now from here is a minus 2x. And what do you do now? Divide by minus 2, divide by minus 2. And therefore, now I can say x is equals to a negative 4. Right? It means the value of x there will be what? Will be a negative 4. Boys and girls, you can check this one. If the value of x is a minus 4, you can just substitute it in there to see g prime of minus 4 there. It's a minus 2 times minus 4, and then plus 2. That will be positive 8 plus 2. Then it's 10. Then here you have 10. Now you can see down this value here is x is equals to minus 4. And you are 100%, correct. Good. I think, boys and girls, I have answered your questions very well. Please make sure that you understand, like we said earlier on, when you talk of the gradient, we are referring to the derivative. If you can keep that one in mind, it's very, very important. Very important. Right. Boys and girls, like I said now, we need to look at the point of inflection. We need to look at the point of inflections of the function. Of course, now we are happy. Now we understand the first 3 steps, which are very, very crucial, boys and girls, before you can sketch the functions. Now, can we now determine what? Can we now determine the point of inflections, right? The point of inflections, of course, that will be the last question here. Determine the point of inflections of f. Right, that is a 2 marks question, right? No, 4 marks question, but I will give you 3 minutes to go through that one. Then after that, we will discuss the question with you. Right.